Hello, I'm Yoichi. May I start?
Yes, please.
Okay. Hello, everyone. I'm Yoichi. I'm connecting from Japan. It is midnight. Outside is very dark. And before starting my presentation, I would like to express my gratitude for the opportunity to present here. All of the workshop on the first day were highly insightful and excellent. I'm truly pleased that such an international conference, ISHP, is being held regularly. Thank you. Now, let's get started. The title of my presentation is Practical Group Decision-Making Method Using Incomplete Pairwise Comparison Matrices for Differentiated Evaluation Result. This is a report on the result of my work on policy evaluation in administrative planning in Okaya City in Japan. Here is the outline of my presentation. I primarily focus on the initiative carried out in Okaya City. This presentation builds on the results I reported at ISAHP 2020 and 2022. At that time, my goal was to propose a method that makes AHP more accessible to the general public. This time, I will introduce how the method I proposed was found to be equivalent to applying Harker method. Do you know Harker method? For incomplete pairwise comparison matrices in the context of AHP. This research began in 2018 with Okaya City's commercial revitalization plan. This first phase of this 5-year plan concluded in 2023, last year, and the second phase began this year. My evaluation method was adapted in the second phase. In Japan's administrative activities, it is considered important to proceed within the framework, the PDCA cycle. PDCA stands for Plan, Do, Check, and Act. As shown in the figure, the plan for the following year is formulated in March, starts in April. And the goals are midterm evaluation in October and November. And from December to February, revisions for the next fiscal year's plan are carried out by administrative officers mainly. Under this plan, 2 meetings are held annually, involving a group of about 10 citizen representatives. In the October meeting, the detailed numerical data are presented. Then in November, based on this midterm report, citizen representatives conduct subjective evaluations for the next year's plan, taking both internal and external factors into account. The evaluation method I am presenting here will be applied during the evaluation conducted in October and November. In this way, while the final evaluation is ultimately subjective, but it is built upon the foundation of accumulated objective evaluations. Let me introduce Okaya City here briefly. This city is an industrial city with a population of just under 50,000 and located near our university. Like many local areas of Japan, this city also faces the challenge of population decline. which has led to financial difficulties. To boost its population, Okaya City decided in 2018 to focus on revitalizing commerce by formulating a commercial revitalization plan. I joined this initiative as one of the members, marking the start of this research. In terms of evaluation, the purpose is to assess the progress of policies and assign an ABC rating to each policy for the next fiscal year. Policies rated A are considered important and high priority, and they are allocated budgets for implementation in the next year. In other words, specific projects are launched based on these evaluations. One role of the committee members is to determine these A, B, or C rating as representatives of the citizens. To achieve this, AHP is used to quantify their subjective opinions through pairwise comparisons. However, comparing 6 policies, for example, requires significant effort, and it is difficult for these representatives, who are often elderly or very busy business owners, to carry out the AHP process. Actually, comments such as, "This is too complicated questions, it's too difficult to do," or "I just gave answer, but they were random," at a committee meeting indicate failure in evaluation. This was the main challenge I faced then. The Okaya Commercial Revitalization Plan can be represented with a diagram like this. P stands for program, but here I will refer to them as a policy. As you can see, there are 11, totally 11 policies. When represented as a familiar hierarchy diagram, it looks like the next slide. For this presentation, I will focus only on fundamental strategy 1. This strategy contains 6 policies. The evaluation criteria for these policies are importance and urgency. This is a questionnaire translated into English. The evaluation fell in the policies in order they consider important from the top of the bottom. For example, P1, the most important project is P1, policy P1, P2, P6, and so on. Next, they evaluate the differences in importance starting from the bottom here. I use the adjective-based scale of AHP. And just like in AHP, we converted it into numerical values. Then I multiply the lower importance values by the corresponding numerical values. For example, more and more is 5. A little more is 3. So 5 times 3 is equal to 15. So the degree of importance of P3 is 15 in this case. And then when normalized, we have these weights. These values represent the evaluation results for each evaluator. This is the same as the previous slide. This is for all participants. The second person is the one we discussed earlier. P1, P2, P3, and so on, P1, P2, P3, and P6, and so on. And their rankings are transcribed here along with the numerical values derived from the scale. By combining these, the evaluation value for each policy is determined. Note that normalization has not been applied here. So this is this one. And finally, to calculate the corrective evaluation value, geometric means of result from all participants is calculated and normalized in the context of HP, and then derived the overall evaluation value. This is the overall evaluation value of a group. This calculation process is intuitive for general evaluators and easy to understand, which participants have found helpful when receiving feedback. Additionally, during meetings, the availability of such numerical data facilitates discussion. The size of these values determines the assignment of A, B, or C rating. For these, differences in relative evaluation values are required. Currently, evaluators also participate in the meetings where these discussions occur. Finally, the results are deliberated and approved during the March meeting. Now, we moved on to the main topic of today's presentation. The importance values calculated in the manner described earlier were found to be equivalent to values calculated using the following method. Specifically, a pairwise comparison matrix is created based on the questionnaire results. Questionnaire makes this incomplete pairwise comparison table, and this results in an incomplete pairwise comparison matrix. Using a Harker method, weights are then calculated. Harker method, at least in Japan, is widely known under his name. As an English explanation, for example, you can find it in Professor Krakowski's book, listed in the references. And using the Harker method, this type of matrix is created from an incomplete pairwise comparison matrix, and weights are calculated based on the largest eigenvalue of this matrix. Specifically, the undefined values are treated as zero, and diagonal elements are set as the number of zero in row plus one, 1, 2, 3, 4 plus one, and so this is 5, and so on. This 1, 2, 3 plus 1, and so this is 4. It was found that the results are consistent with the method discussed earlier. What this calculation revealed, and that in practice, we are estimating the following pairwise comparison matrix from the incomplete pairwise comparison matrix. I noticed that the numbers significantly larger than very large and larger than 9 are used here. This is a major difference from AHP. Additionally, it becomes clear that this method is not aimed at estimating latent relative evaluation values as in AHP. Rather, in the context of voting, the goal is to quantify the evaluator's subjective judgment. Let us let us revisit the context of incomplete pairwise comparison matrix in the AHP. But I'm sorry, but I have a little time, so skip this. And we have a lot of limits. As you can see, the method I proposed here is very difficult to use in ordinary situation. And then conclusion, as you can conclusion, and the use of HP in group decision making in administrative activities context remains limited, at least in Japan. Challenge includes the occurrence of inconsistent pairwise comparison matrices and the difficulty general citizens face in conducting numerous pairwise comparisons. These challenges could potentially be resolved by devising innovative approaches to structuring questionnaire questions as shown in this paper. On the other hand, with a widespread adoption of pairwise comparisons in AHP, it is expected that AHP with a complete pairwise comparison matrix will be utilized to estimate the potential value of policies. And this concludes my presentation. Thank you very much for your attention.
Thank you. Thank you, Professor Lira. Well, there are several observation questions, but I will just limit to two. Well, number one is probably this method should be, it's a method that you have created, is very interesting, but it's not really AHP because the way, at this point, the way a survey is conducted, a survey is conducted, and we're using like a Likert scale to really indicate which is the most important project, right? With the P1, P2, how important is directly, how important is the project? So you fill it in a matrix, but this is not a pairwise comparison matrix because that's not the way the judgments were obtained. So that would be the first observation any AHP practitioner would say. So you're beginning the initial judgments in this incomplete matrix have not been obtained by pairwise comparison. And the second observation is that while you're using the Harker's method, the method that Pat Harkes developed is one of the possible. There are many different methods to fill in an incomplete pairwise comparison, and the most common one is really using the diagonal above the ones. So the question will be why the Harkes method and why not just using the line above the diagonal? I don't know. I noticed that again, our conference chair, Professor Monica Garcia Melon, is here, and I don't know whether you have any observations, Monica.
Yes. Also, thank you very much for your presentation.
Thank you,
Yoichi. Yeah, I wanted also add another comment on that on top of Enrique's. When you use your method, you said the numbers are larger, much larger. I've seen that from 1 to 900 and something, yeah, at the end. So one of the things that AHP is very insistent in is that we cannot compare things that are one scale farther. So from 1 to 9, and that's too much, even too much, because we cannot perceive the difference, or we cannot compare things that are so much different. It seems, as far as I understood, that with your method, you can have things that weight 1 and others that weight 900, which is 1,000 times bigger.
Okay.
So that it's a little bit confusing for me, because with such broad spectrum, our mind, it's not a matter of mathematics. With mathematics, we can do anything, but our mind is not able to compare these things. And we are comparing all of them in the same matrix. So I wonder, so my question is, how do you deal with that?
I don't care the big number because in this case, about 10 evaluators judged, and combining the results by geometric means. So I don't know that is problem. In this case, my main goal is to obtain the I don't know, evaluations which are very different numbers, values, because our aim is to decide ABC for ABC rating for all policies. For example, policy 1 is selected as A rating in the next year. Policy 1 is will get high budget. And so we construct a big events. And so revitalize commerce in Okaya City. So the purpose of this method is we decide A, B, C. In particular, A is very important because related to the budget in the next year. So the differences is very, we need differences of evaluation values.
Yeah.
Okay.
Okay.
Well, we need to move on, but
Anna is wants to ask a question. Also,
Very short
Enrique.
question. A very short question. I think it's something related to what Monica said. I was also wondering, because can you move back to your slide number 9, I think, when you said, because I was listening, you said about the meaning is 15, but it didn't say, no, one before, I think. It's not 9, maybe it's 8.
8.
Can you present the slide, I think one before. Yes, here. When you said that after the calculation, for example, the meaning of the element is 15, and we can see here the huge difference between 5, 15, and 945. So what does that mean? Did you group them because there are huge differences between one element and the other? How to explain that, for example, to, if you apply for some project and if you publish your paper, you need to explain your results, yeah? So how to explain this kind of meaning, the huge differences between one element and the other?
I'm sorry, but huge difference. Basically, Sati's fundamental scale is a little more, is 3, 5, 7. I use the scale. So for than the
but
6th place.
the SATI fundamental scale is 9-point scale from 1 to 9.
Okay.
Yes,
And
it's 9 point. Yeah.
Yeah, and it's a ratio scale also. This is not a ratio scale. I will suggest this. We can be discussing afterwards, but I understand, this is a method approach that has been developed for the specific needs. But don't call it AHP, because as soon as you call it AHP, people expect, I expect, I'm sure, a very specific way of doing things corresponding to AHP. And definitely, thanks God Tom Sat is not here, but, beginning with this scale is fine for your purposes, but it's not a ratio scale to fill in pairwise comparison matrix. So if you don't use the word AHP and you use based on pairwise comparison methods, because there are many pairwise comparison methods, I think this contributes to the literature and way to make decisions in that area. But when you call it AHP, then you attract a lot of I would say criticism, but a lot of questions, because you have definitely departed from AHP. And we have to move on, because we have 4 presentations. There are 2 more to go, but we can chat at any time after that. But thank you very much. It's a very interesting, thought-provoking presentation.
Thank you very much. I think myself, this is a big challenging issues.
Thank you.
Thank you, Yoichi. Nice presentation.
Thank you very much.
Yeah.